Today we're going to talk about square root functions and inequalities. I'm working from section 7-9 in your textbooks, but this is a picture taken directly from your book, but I really like it because I feel like it gives you a good visual. It says if a function contains a square root of a variable, it's called the square root function. Like you can see down here, we've got y equals plus or minus the square root of x. So we're talking about square root functions. The inverse of a quadratic function, remember the quadratic is something like y equals x squared plus 2x plus 3. So the inverse of that is the square root function. But the difference is that with the quadratic, we can have x values that are negative and positive, but the range is restricted in a square root function to non-negative numbers. And we talked about this before. We cannot take the square root of a negative number. So if I had the square root of, let's say, y equals negative 3, we know that this is an imaginary number. You can't take the square root of a negative number. That's why the function y equals square root of x, the domain, that's the x values, have to be positive. We can't have a negative under the square root and be able to graph it. So that's why this is not a function. This, however, is a function. So in order for the square root to be a real number, the radicand, the number inside here, cannot be negative. When graphing the square root function, it says determine when the radicand would be negative and then exclude those values from the domain. So that's what we're going to do in this problem. We want to know when will this be, this right here, be 0. We want it to be greater than or equal to 0 because it can't be less than 0 or it will be negative. So we've got, let's see, my mom keeps texting me, interrupting my video. Sorry about that. We've got the square root of 3x plus 4. Okay, well, everything under here is the radicand, so we just want to look at the 3x plus 4. We know it can't be a negative number. It could be 0, so it could be equal to 0, or it could be bigger than 0. If it's less than 0, then it's going to be negative. So let's just solve and see what values of x this is true for. So we're going to minus 4 from both sides. So we have 3x is greater than or equal to negative 4. At this point, to get x by itself, we're going to divide both sides by 3. So x equals, x is greater than or equal to negative 4/3. So you could make you a table now starting with x values at negative 4/3. So I went ahead and filled out my table here, negative 4/3. When x is negative 4/3, if you plug it into the original equation here, you get y equals 0. When x is negative 1, y is 1. When x is 0, y is 2. When x is 2, y is 3.2. And then I kind of sketched out a graph here. So this is the graph of y equals the square root of 3x plus 4. You know the y-intercept is positive 2. Because when x is 0, y is 2. We know that the x-intercept is here at the negative 4/3. So it crosses the y-axis, the x-axis at negative 4/3, crosses the y-axis at positive 2. Okay. Let's say I give you this function, y equals the square root of 3/2 x minus 1. And I ask you to find the domain, the range, the x-intercept, and the y-intercept. Well, all the domain is what are the possible x values, and the range is then what are my possible y values. We know that this under here cannot be a negative number. So the 3/2 x minus 1 must be greater than or equal to 0. So I'm going to start by solving. So I have 3/2 x has to be greater than or equal to 1. To get rid of a fraction, I multiply by its reciprocal. So I know that x has to be greater than or equal to 2/3. So that's my domain right there. All of the values of x have to be greater than or equal to 2/3. So if I plug in these x values of 2/3 or greater into my function and solve for y, that's going to tell me what my range is. So let's do that. If I plug that in, I end up with y is greater than or equal to the square root of 3/2 times 2/3 minus 1. We know 3/2 times 2/3 is just 1. 1 minus 1 is 0. And the reason I said that has to be greater than or equal to 0 is because I'm plugging in x values that are greater than or equal to this 2/3. So if I'm plugging in 2/3 and that number just keeps getting bigger and bigger and bigger, of course this number is going to keep getting bigger and bigger and bigger. So my domain is all the x's greater than or equal to 2/3, and my range is all the y's greater than or equal to 0. So at this point we've got to find our x-intercept and our y-intercept, which we already know what our x-intercept is, because when x is 2/3, y is 0. So that makes this our x-intercept. 2/3 is the x-intercept. Now we've got to find the y-intercept. So I want to know what is the value of y when x is 0. Well, x can never be 0, because if I plug 0 in, I'd have 3/2 times 0, which would be 0, minus 1, which would be a -1. We can't take the square root of a -1. Graphically, that would not yield us a real answer. It would be imaginary. So there is no y-intercept. Your assignment is to graph y equals the square root of x, and then outside of the square root is -4. And I also want you to graph y equals under the square root x minus 4. So here my radicand is just x. Here my radicand is x minus 4. Graph those, and then I want you to compare and explain why those two graphs are different. What happened from one to the other. And then the rest of your assignment is page 397, numbers 4, 5, 6, and 7, and page 398, 14, 15, and 16. These are to be turned in before you leave. They will be graded as to whether they are correct or incorrect. You are to show your work. When you're finished with this, I recommend starting on your blizzard bag assignments. Also, be sure to turn in last night's homework, page 261, numbers 4 through 9. So you'll be turning in three things. Your video notes, homework from last night, video notes, and this assignment right here, along with this up here, and then work on your blizzard bags the remainder of the class period. Hope you have a good day without me.